Let's look at the 5th grade textbook, chapter 4, subtracting mixed numbers from exercise 7 and exercise 8. I'm going to pull a problem from 4-7, page 91, and I'm going to show you some of the methods that we could use to solve it. The first method I'm going to show you is changing mixed numbers into improper fractions. Let's do so. I know that 7 and 4/7 can be changed into an improper fraction by realizing how many are in a whole. A whole here would be 7/7. And because I'm going to have 7 of those wholes, and I actually need 7 of them, I'm going to multiply 7 for my numerator times 7, how many times I would be adding it to itself, which is 49, and I am keeping my original denominator. Now I have 4/7 left over. I've changed the whole 7 into an improper fraction, and I'm going to add in my 4/7 that are left over. All right, and that would be 53 over 7. Now we can look at subtracting. All right, because these already have a common denominator, I don't need to find that, but I can go ahead and simply subtract the way that it is, and that would be 48, 53 minus 5 for our numerators being subtracted is 48, and it stays over 7. I would simplify this as well. Another method for doing this is to subtract from a whole number. So for instance, we could have, instead of changing this mixed number into an improper fraction, I could have gone ahead and simply created a number bond here for my mixed number, and I could start typically with my whole numbers I would subtract, but I don't have a whole number to subtract in my second part of the problem. But I do have a fractional piece, and if I moved on to the fractional pieces, I would be looking at 4/7 minus 5/7, and I can't do that. What I can do though is I can take 7 and 4/7 and turn it into something that's different. So I know that 7 can be represented, 7 wholes can be represented as 6 wholes and 7/7. I know that because 7/7 actually is equal to a 1, and I know that 6 plus 1 does in fact equal 7. So what I have now is 6 wholes and 7/7. But remember, our original mixed number was 7 and 4/7. So instead of just deleting this, we're going to come down here and we're going to add it back in. And the reason for that is because we're trying to get a larger number to subtract 5/7 from. I know that adding these together would be 6 wholes, and then I can add the numerators here of my fractions, 7 and 4, which is 11/7. And now I can go ahead and rewrite my problem. So all of this is the rewritten version of 7 and 4/7. I'm going to drop down or rewrite the remainder of my problem here, which is minus 5/7. So here we go again. I can subtract my whole numbers first. 6 minus nothing is 6. And then I can move on to my fractional pieces. 11 minus 5 is 6 over 7. This would be the next method that we could use. Let's take a peek at some that aren't as simple. Let's say that we are looking at a problem like 8 and 5/12 minus 1/4. The first thing that we could do is we could go ahead and find a common denominator between our fractions. I typically do this as a T-chart, putting one denominator on the top and the second denominator on the bottom, and I would list out the multiples until I found one that matched. The first one that matches is 12, so I'm only changing one of these fractions because only one of them needs to be changed to have the denominator 12. The first fraction, 5 over 12, already has that. So 1/4 I'm going to be changing. I'm going to do it over here on the side so that we can see it. And remember, I'm trying to turn it into something over 12, so I'm going to write it over 12. I figure out what I'm multiplying by, and I know that it's 3. So I'm going to multiply by 3 on the top as well. 1 times 3 is 3. My new fraction is 3 over 12, so I can rewrite my problem. 8 and 5/12 minus my new fraction of 3/12. Subtract my whole numbers first. 8 minus nothing is 8. And then I move on to my whole numbers. 5/12 minus 3/12 is 2/12. And I can simplify that as well. I know that 8 will stay 8. 2 can be divided into 2 and 12 evenly. So when I divide by 2 on both of those, two divided by 2 is 1, 12 divided by 2 is 6, 2/12 is the same as 1/6. So I can rewrite my simplified fraction as 1/6. Let me show you one more where our second number is larger than the first one. All right, here we go. Let's look at letter D from page 91. Here we go. The question asks for 4 and 1/3 minus 5 over 6. Okay, so again, we have multiple options. We can go ahead and find a common denominator. We can change our mixed numbers into improper fractions and then find equivalent fractions and common denominators. And sometimes we can go ahead and we can subtract by changing our mixed number into a whole and an improper fraction as one. And we're going to follow a mixture of some of those here. So first things first, I need to make sure that I have a common denominator. So I'm simply going to be looking at the fractional parts of this problem. I'm going to be looking at 1/3 minus 5/6, which I can't do because they do not have the same denominator. Let's find that common denominator by creating our t-chart and listing the multiples of each of those denominators. I can already see a match. 6. Thankfully, our second fraction has 6 as that denominator already, so we're only going to be changing the denominator for the first fraction. So I want 1/3 to be something over 6. What did I multiply by? 3 6. I multiplied 2 times. Do the same thing to the top. And I ended up with 2 as my new numerator. So I'm going to rewrite our problem as 4 and 2/6 minus 5/6. So here's where it gets a little bit tricky. We're looking at 4 as our whole number, because we can subtract our whole numbers first, minus absolutely nothing. Easy. 4. This is where it gets tricky here. 2 6 minus 5 6. I can't do that. So my original thought of putting down 4 is not appropriate here. That's just a little bit of trial and error that happens to come with math. So what I need to do instead is I'm going to create a fraction that can actually be larger than the fraction that's being subtracted. So I know that 4 can be represented as 3, and since our denominator is 6, a whole would be 6 over 6. So that would be 3 plus 6 over 6, which equals 1, does indeed equal 4 wholes. So now, knowing that, I can include the 2 6 that was already there in my mixed number. What I'm looking at now, if I rewrote this, would be 3 as my whole. Putting together my two fractions here, I would have 8/6. And now I can actually subtract my 5/6. Now we look for our whole numbers. 3 minus nothing equals 3. 8/6 minus 5/6 equals 3/6. And with reducing would be 3 1/2.